When we look up in the night sky, we see hundreds of stars that appear to be dispersed quite evenly. Galaxies and clusters of galaxies were formerly thought to be uniformly distributed throughout the cosmos, similar to raisins in a cake. Each highlight represents a galaxy cluster or supercluster, but then this delicate and lovely picture of the universe fell apart. Scientists spotted big holes instead of raisins, as if someone in our cupcake had taken out a lot of the raisins. How do you feel about a 2,953,000,000 light-year void? How did these vast expanses of almost nothing come to be? What is the distance between us and the nearest bleak formation? And perhaps most unexpectedly, is there a link between such vast spaces and alien civilizations? Welcome to Cosmos Observer, the only destination for your space curiosities, and today we will be covering our topic about Boötes void, the supervoid. Stephen Gregory and Laird A. Thompson of the Kitt Peak National Observatory were the first to discover black holes in the universe in 1978. They are known as voids. Scientists quickly discovered that the universe's structure is far more intricate than previously assumed. Superclusters of galaxies are extended in the form of threads, 163 to 260 million light-years long for some reason, and the universe is a massive three-dimensional web or network. There are only voids between the threads of this network, with an average size of 30 to 50 million light-years. But having moved from a cupcake to the web, scientists have drawn a new view of the world for themselves. The universe then dealt another blow. A void of 330 million light-years was discovered in the constellation Boötes in 1981, and this is 0.27% of the observable universe's current circumference of 93 billion light-years. Supervoids are such massive voids, and there are many of them. How did such massive holes emerge? Galactic thread creation was initially explained. We needed dark matter to accomplish this. According to the standard model of universe evolution, galactic threads emerge and follow network-like flows of dark matter. Dark matter is thought to be responsible for the universe's macrostructure. Dark matter draws baryonic matter gravitationally, and astronomers see this ordinary stuff in the form of galaxy supercluster walls and threads, and the appearance of voids is easily explained. Because baryon matter attracts stars, the concentration of stars and galaxies near dark matter flows grows, whereas it decreases where there are no flows. The attraction of iron filings on paper in a magnetic field is quite similar to this. They are also clustered along magnetic lines, which become visible. However, this explains how voids, emptiness between galaxies, form. But how did supervoids, which are larger than these lines, emerge? After all, the enormous vacuum in the constellation Boötes is a one-of-a-kind location. To begin with, it has an almost perfect spherical shape. Secondly, it is practically empty. Only 8 galaxies were discovered at first. However, more investigations found 60 galaxies spread out over 250 million light-years. According to astronomer Greg Aldering, if our galaxy, the Milky Way, had been at the center of the Boötes void, we would only have discovered the existence of other galaxies in the first 60 seconds of the 20th century, when powerful telescopes with mirror diameters of more than a meter appeared. And the night sky above us, filled with numerous dazzling stars, would not be as lovely. In a perfectly black sky, there would be a couple of stars, or perhaps there would be nothing. However, if the Earth had been in the Canes-Venatici supervoid, which is located in the Canes-Venatici constellation and is currently the 6th largest supervoid, we would most likely not have seen more than a few stars in the sky. There are just 17 clusters of galaxies in this huge gap, which spans 1.3 billion light-years. Furthermore, they are concentrated in a 160 million light-year diameter spherical zone. That is, it is nearly 10 times smaller than the entire supervoid. If we find ourselves at a distance of 600 to 700 million light-years from this region, we will be treated to an entirely dark sky. People would not be aware of the existence of stars for an extended period. Yes, even in the far future, traveling to other stars would not be an option for humanity in this circumstance. Fortunately, the distance between us and this bleak region is only 1.5 billion light-years. So even though we are on the outskirts of our Milky Way galaxy, we live in a very bustling region. In a 3 million light-year wide region of space, we have roughly 24 neighbors. Given that the typical distance between galaxies in the universe is several million light-years, the Boötes void, with a similar density, would contain approximately 10,000 galaxies, and only 60 of them exist. According to computer simulations, such voids cannot emerge in the same manner that typical voids do. Since the beginning of the universe, there has not been enough time for gravitational forces to clear this much space. In an attempt to discover an answer, a new idea was developed, stating that the merging of smaller voids generates supervoids. Aldering found that void galaxies have strange tubular formations, which he believes are key clues. He also proposed that the Boötes void was generated by merging smaller voids, similar to how soap bubbles join to form one large bubble. The tubular galaxies, on the other hand, are most likely the remnants of smaller void barriers. It is also feasible to imagine a more extreme account of events, which has received little attention in the scholarly literature. As a result of the expansion of a highly evolved civilization, the Boötes void could form. The bubble of civilization grows in the direction of the native civilization system, obscuring every star and subsequently every galaxy in its path and covering it with a Dyson sphere. That is, a sphere that absorbs all of a star's radiated energy. It directs it to the needs of civilization. From afar, it appears that there is no star in that location. This could also explain the void's uniform spherical shape. Given that the void of Boötes is approximately 700 million light-years from Earth, and that sentient life in the cosmos could have emerged around 4 billion years ago, such an ancient society would have had plenty of time to achieve this incredible feat of cosmological engineering. Yes, this is just guesswork, but given the peculiar nature of the phenomena, such a concept is plausible. The gigantic gap in the Boötes constellation has been discovered for more than 40 years. Many more supergaps were discovered during this time, some considerably larger than it. The supervoid in the constellation Boötes is now merely the 71st brightest star in the sky. And who grabs the top spot? Lo's North 13788 is the supervoid. We have already discussed its enormous size, about 3 billion light-years. There are just 109,066 galaxies in it. Let us now address the final question posed at the start of this video. How distant is our planet, our solar system, from the nearest supervoid? A distance of 0 kilometers is the answer. We are indeed inside a supervoid. Scientists discovered inconsistencies in Hubble constant estimations using galactic supernovae and Cepheid variables and data from the cosmic microwave background and baryon acoustic oscillations, which characterize the universe's rate of expansion. The Hubble constant in the first example was 72 to 75 kilometers per second per megaparsec, 68 to 67 kilometers per second per megaparsec in the second. The notion that our planet is in a giant vacuum has been proposed to explain the disparity. Outside the emptiness, galaxies feel a gravitational attraction, resulting in a greater local value for the Hubble constant. This giant vacuum, which is smaller than the Lo's North 13788, is estimated to be around 2 billion light-years across. The astronomers Ryan Keenan, Amy Barger, and Lennox Cowie researched it in 2013 and dubbed it KBC Void. It encompasses the Milky Way, the local cluster group, and most of the Laniakea supercluster and is estimated to be approximately spherical. Many scientists, however, believe that this explanation contradicts other evidence and does not adequately explain the disparity in Hubble constant measurements. The existence of the Boötes vacuum and the Lambda-CDM model of cosmic evolution appears to have no serious problems. The Boötes void is thought to have been generated by the merging of smaller voids, similar to how soap bubbles combine to make larger bubbles. This would explain the minimal number of galaxies found in a roughly tube-shaped region flowing through the void center. The Boötes void has been linked to images of BARNARD 68, a dark nebula that does not allow light to pass through. However, BARNARD 68 images are much darker than those seen in the Boötes void because the nebula is much closer and has fewer stars in front of it, as well as being a physical mass that blocks light.